Hi, here, Miss Marion. Let's go ahead and turn to page 134. We're going to look at the I can statements for lesson 3. And it's I can scale and label a coordinate axis in order to graph a proportional relationship. Go ahead and write yourself a sentence on how you feel about that right now. And then go ahead and give yourself a number 1 through 4. So 1, I don't remember. 2, I kind of remember it. 3, I do remember, but don't ask me to teach it to anyone. And then 4, I can actually teach it to my friend. So let's go ahead and let's turn to page 25. This is the first part. And what you want to do is you want to go ahead and find the values of each product mentally. Mentally means you're going to do it in your head. Think of a process to go ahead and do that, and then we can go ahead and do that together. All right, let's go ahead and go through these. 15 times 2. So I know that I have 2 15s, and I can go ahead and add that together. And what is that going to end up equaling? Well, that can equal 30. So 15 times 0.5. So think about it mentally. How do you get it? And so we can do it as it's 0.75. 15 times 0.25, which is 1/4. So 3.75. So that's kind of like half of the 7.5. And then 15 times 2.25. I can multiply 15 times 2, so that gives me 30. And then 0.25, that is the 33.75, or sorry, 3.75. The answer is 33.75. Okay, so this kind of helped us think about things, getting our brains thinking about just math in general. This is actually from yesterday. Was the paper as far as what we did, and we did the equations, and went ahead and went through those and to figure them out. And as we can kind of remember, so card A was y equals 1/4. Card B is y equals 3x. Card C was y equals 7/2x. And I know that that's 3.5 or 3 1/2. I do want it as an improper fraction. I'm being really picky right now because it's going to help us later on when we're graphing. And then card I, yes, I know it's out of order, is y equals 4/3x. Yes, I know that's 1 1/3, but again, I want it as an improper fraction. And then the last one is y equals 5/2x. Okay, so these are all the equations that you should have gotten as far as the different ones. And then if you do the rest of the page, and this is actually found at the top of the Canvas page, lesson page, and if you do the rest of it, you can actually kind of see how the different graphs are, they can have the same equation, but the graphs look different, and it's because of the scale. So it depends on how it's labeled. So here is the answers for the rest of them. So, and I don't know if you did this on the last lesson. I just want to make sure we understood what it was, because we're going to kind of use some of the information for today. All right, now let's go ahead and get into the nitty gritty. On page 26, we have 2 representations, okay? So here we have Jada and Noah. They count the number of steps. Jada took 8 steps, Noah took 10 steps, and then they found out that Noah took 15 steps and then Jada took 12 steps, okay? And we can actually take this and we can put it into a table, okay? And that same information it ends up actually being this y equals 5/4x, and we're actually going to talk about the table and different things and be able to go ahead and graph them. But first of all, let's talk about tails. The same kind of tails that is in science. So when we are doing graphs, we need a title, axis, I is interval, L is labels, and S is scale, or scales. So remember, when we are doing graphs, and the same thing as in science, we actually want all of these things to be able to go ahead and do a graph and do it correctly and get 100% on that. Write all of this down on page 26 underneath this question. You need to have it written down so when we go to do the graph, you know what it is. So pause for a second, go ahead and write it down, and then we'll actually talk about more of what we're doing. Alrighty, so now again we are looking at as far as the different stuff with different representations, and we're going to go ahead and we're going to take the information that we have, and we're going to put it into a table. And the way that we're going to do this, and go ahead and write this also on page 26. We have the X and we have a Y. And so the X is Jada and Y is Noah. So Jada took 8 steps. Noah took 10 steps. And then, as we said, we had Noah was 15 and then Jada was 12. So this table also represents this equation. And I'm going to kind of show you how we go from this table to get this equation. We're going to do it really, really quickly. And so what we're going to do is we're going to kind of do the same way that we did before. We're doing the y over x. So technically, the triangle, the right triangle that we're looking at, the first point is 0, 0. This top point is 0, 8, 10. And if we did it, we did y minus 0, okay? And then x minus 0, and then we put in the y, so the vertical, which is 10, horizontal, which is 8. So technically it's y over x, and you might want to pause this and like rewind it if you don't understand. But the format that we're doing is y over x equals 10 over 8. And then what we do from here is we're going to cross multiply and divide. So we're going to cross multiply. And then we are going to go ahead and we're going to divide. And so 10 times x is 10x. 8 times y is 8y. And then we're going to solve for y. And I'm going to show you in a second the reason why. So we're going to divide by 8 on both sides. And so we're going to have 10 over x, 10 over 8x, and then we're going to have y. And if we actually take that 10 over 8 and we simplify it down because it's a fat fraction, we want it as skinny, this is where we get the 5 over 4x equals the y. So notice how what we just barely did makes the equation that we have, and we pulled it from the table. And we're going to do this again, so don't worry about that. But what we're going to do is we're going to take all of this information. So we know that this table and this equation go together, and we're going to go ahead and we are going to draw all of this on our workbook. So on page 26, here's the graph. You need to go ahead and label it. So you need a title, you need access, you need a interval, you need a label, and you need a scale. I want you to go ahead and graph all of this as far as the situation between Noah and Jada as far as the steps that they have. So go ahead and pause right now, go ahead and graph it, and then see what you get. All right, here are some examples as far as graphing Jada and Noah's steps. As you can kind of see, it down on the bottom, here we have Jada's steps. So that was our X. Here are Noah's steps. Here's our Y. This actually needs a title, so Noah and Jada's steps is actually the easiest way to do it. Notice how they put a point on here. It does go through 0, 0, because we talked about that yesterday as far as if we have the Y equals 5 over 4x, it will always go through 0, 0, and then they're able to go ahead and graph that. So to go along with this question, question C, if we look at it, it says, how can you see or calculate the constant of proportionality in each representation? So what does that actually mean? How can we do the slope? Or the K value is really what it's looking for. So on our graph, we can go ahead and we can do a point, like pick a point, and then we can go ahead and find our X and our Y kind of stuff. So if we actually pick here, notice how it's 5 and then 4. So we have 5 over 4 is our slope. And yesterday we did y equals our slope multiplied by x. So that's y equals 5 over 4x. Also, we can go ahead and we can find the constant of proportionality. We can actually find it through the table. And so what we can actually do is we can do our, let's see, we make a right triangle. We start at 0, 0 because it's a proportional relationship. And we pick this top point. So we have it as 8, 10. Okay. And then we can go ahead and we can do our vertical. Our vertical would be 10. Horizontal will be 8. and we can make an equation just like we did last unit. We're going to leave it as y over x because it's 0, 0 where we're taking it from. Let's go ahead and put in our information that we know. So we can go y over x. Our vertical is our 10, horizontal is our 8. So we have 10 divided by 8. And then we can go ahead and cross multiply. And so if we do 8 times y, we have 8y. 10 times x is 10x. And what we're really trying to do is we're trying to make our equation that we did yesterday, so the y equals kx kind of information. So we want to go ahead and get y by itself. So 8 and y are multiplying each other, so we are going to divide by 8. 8 divided by 8 makes 1, or at least 10 by itself. So we have 10 over 8, and we can reduce that down. We can take a 2 out of both of them. And our final equation, let's go this way, is we're going to have y equals 5 over 4x. So again, this is a way of actually pulling it from the table, as we can kind of show that 5 over 4 is our slope, or our constant rate of proportionality that goes along with our proportional relationship. So again, here is example number 2. So here's a description of the Origami Club is going a car wash fundraiser to raise money for a trip. They charge the same price for every car. After 11 cars, they raise a total of $93.50. After 23 cars, they raise a total of $195.50. So what we want to do is they ask us to go ahead and write an equation, and then they talk about this C letter and this and letter. We're going to write the equation first, just as like y equals kx, because we just barely did that, and we know how to do it. So I'm going to take this top point. So again, it starts at 0, 0. I'm going to make a right triangle. We have 11, 93.50. Oh yeah, sorry, I forgot to talk about independent and dependent variables, right? So we have it as, we're talking about number of cars, and we have dollars. So the amount of dollars depends on how many cars we actually wash. And so if we want to label that kind of stuff, this is our dependent. And depends are always our y, and number of cars is our independent, and it is always our x. So that's why I have the point as the 11, 93.50. So our vertical is the 93.50. Horizontal is 11. Put it into the y over x, vertical over horizontal. So we have y over x. Vertical is 93.50. Horizontal is 11. Again, we're going to cross multiply and divide. Unfortunately, I have to move it all the way down here. Okay, so 11 times y is 11y. 93.50 times x is 93.50 x. Again, we want to go ahead and get y by himself. So 11 and y are multiplying. We are going to divide by 11 on both sides. So we're going to get y equals 850 x. And because we're dealing with money, I like to keep it as 850 and kind of look at it that way. Kind of, it'll make it a little bit better brain. Okay. And then now we need to go ahead and use our C and then our M. We're going to take this equation and we're going to put our C and our M into it. So notice how the dependent is y, and that's the money. And they want us to use M for the money part. So we are going to rewrite this equation so that it's M as the money equals 850, and C is the number of cars, and it's also the X. So this equation down here, the M equals 850C, is actually what we're working with. And that is our equation that we're supposed to do for A. So from here, you're going to go ahead and you're going to graph. So again, we're doing tails. So title, axis, interval, labels, scale. And you need to go ahead and decide how you're going to go ahead and graph this. So you want to pause right now. You want to go ahead and graph it. And once you have done that, come back to me. So here are two examples, actually three examples of how to graph. This one is okay here, but I don't have my X and Y axis labeled, and I also don't have a title. So if you did this actually on a quiz or a test, it would actually be marked down because it does not have all the information. Notice how this one here, we did it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as far as the number of cars, so going up by 10, up by ones. This one is going up by 850. So for one car is 850, two cars it's 17, three cars it's 2550. And so notice how they did that scale. Okay. This one does need a title also, but this one's a little bit better. And then this one's okay also. Their Y axis is a little bit different than this one over here. But again, we do need titles for all of these. So these are really, really good examples. So C says, how can we calculate the constant rate of proportionality? Again, we can go ahead and do slope triangle to go ahead and find a vertical and a horizontal. And then just like we did before, we actually found the equation. We took it from the table. We went ahead and found that y equals kx. So k is also known, let's kind of write this down. K is known as the slope. It's also known as the constant rate of proportionality, and it's also known as the rate of change. Now the rate of change, we were working with the equation y equals 8.50c. The rate of change, a lot of times have to deal with a story problem, and then it also has that the denominator is 1. So this is kind of a little bit different, but rate of change is actually something new. We are actually going to go ahead and skip the problem card kind of stuff, so don't worry about it. We're skipping this one also, so again, don't worry about it. Again, this one we're going to go ahead and skip. And then again, we're talking about proportional relationships, right? So again, we can go ahead and we can find a constant rate of proportionality either through the graph or also the table. Go ahead and turn to page 31, and what I want you to do is there is the glossary term, and it is for rate of change. On page 31, there's an area. What I want you to do is I want you to do a definition for rate of change. So either you can copy down my mathematical one, do one for yourself, but remember it is for a story problem. We are finding the slope, the k, or the constant rate of proportionality, and the amount changes is increased by 1. So like that bottom part is 1. Go ahead and take a second, go ahead and do a definition, and come back. All right, go back to page 133. Go ahead and give yourself a sentence about today's lesson, about I can scale and label a coordinate axis in order to graph a proportional relationship. And give yourself a number. So 1, I don't remember. 2, I kind of get it. 3, I did get it. But 4, I cannot go ahead and teach it to my friend. Make sure you do the practice problems for lesson 3. So make sure that is done. And have a good day. Bye.